x?
We normally write v as function of x as the volume, but f of x is fine too. You can use f if you like. What now?
Length on this side.
Awesome. Length times width times height. Good. I'm going to replace all of them. So 20 minus 2x, 12 minus 2x, and x. When I multiply something like this, it is highly recommended to FOIL first and at the very end distribute x. Do not start with x. So 20 times 12, it's 240. 20 times negative 2x is negative 40x. Negative 2x times 12 is negative 24x, and then plus 4x squared, and everything will get an x. I will combine like terms inside. And then,
4 squared.
yes, times x, so it's 4x cubed. Then this will be negative, you're right, do it in 2 steps. You don't have to do it in 1 step. Negative 4, very good. X squared, very good, and plus 240x. So part A is answered. So we determine the volume of a box in such a situation. Part B, find the values of x for which the volume is greater than 200 cubic inches. How do I write part B? Hold on, Lima. I didn't hear. I have this band is covering you sometimes, so I apologize. If you'd like to tell me what to write.
The same thing, just with a greater sign over what number did you say?
It said, one more time, 200 cubic inches. So the volume of x greater than was greater than, right? For which the volume is greater than. Very good. Or equal to. It says greater than, so it's not equal to. 200. Good. So then I have 4x cubed. Very good. Minus 64x squared plus 240x minus 200 greater than 0. Now again, I'm going to stop and ask you, what is it?
What were you asking about the equation?
It's an inequality.
Yeah.
What type?
The chart.
Charts are solving
just did it.
inequality.
No, we didn't do it.
No, is that quadratic?
Right, Paul. It's not quadratic. So what is it?
Cubic.
Awesome. Very good. It's a cubic inequality. The procedure will be the same if I can factor and if I can find the solutions. Yes, I'm really hoping that I can get rid of 4. Absolutely. Why? Because we said there are 2 action words in this class and all math classes. What are those 2 action words?
Factor and simplify.
I couldn't say it better. So I have x cubed. I have minus, what is it?
We're not allowed to take the x off.
16.
But is x present in all 4 terms?
Oh, I didn't see 200.
Oh, no.
So 64 divided by 2 is 32. 32 divided by 2 is 16. Plus 60x and minus. Good. So now we are getting into the habit of simplifying everything we see, correct?
Mhm.
Are we getting closer to that? To get into the habit? Okay, perfect. So now, obviously, this is not factorable. Yeah, I think it's on max heat. It is on max heat.
There is no.
There is no heat. I agree. I agree.
That's my answer.
Good.
Wait, just turn off that light.
There is a way of
The middle light.
They're turning off that light above the.
here, this one.
No,
No, on the ceiling.
Ceiling.
On the ceiling.
it wants to turn off that light because it has a glare on.
Oh,
Think about how they turn off the whole front.
Yeah, that's not. If you can.
It's better. It's better. It's much better.
whatever it takes.
There we go.
Good. So this is not factorable.
Right.
I will have to find the solutions using a graphing calculator. Another possibility will be to graph. Okay. So that's another option. If you don't want to use the chart, you can graph. Sometimes graphing, I think, is more difficult. If it's factorable, I would never use the graph, but you can. Okay, so in y equals, let's put in this function, which is x cubed, and then minus 16x squared plus 60x. And I was going to say that if you stick with me, you're going to learn what you haven't learned in the previous class and way more. Way more. Okay, so now let's think for a moment. What does x represent?
Height.
The height of the box.
Yes.
How small can it be?
0.
Still impossible, right? Okay, let's say 0. How big can it be? Don't say anything just yet. If you remember, the box had 20 and 12. How big can it be? If it's 6, I don't have a box. So it cannot be more than,
It has to be less than 6.
of course. This is crucial because that's where I'm going to put the numbers in. I don't care for the whole graph in the world. I only care what happens between 0 and 6. That's how I determine where the action is and what I'm interested in. So x minimum 0, x maximum 6, and scale of 1, y minimum. We're talking about true, but we're not really graphing the volume, right? We have that minus 200 in there.
Yeah.
Okay, so, but obviously I don't expect anything to be negative, right? So 0 for y. Y maximum, I have no clue. I have no clue. I'm going to go to 1,000. And with a scale of 200. And now I click graph and see what happens. I'm way high. Okay, I go back to adjust. I'm going to change the y maximum to 200 with a scale of 50. And I'm going to graph again.
What is the scale do?
The tick. Okay, so coming back, don't say anything just yet, 1 second. What are we trying to determine?
Values of x.
Values of x that make this expression positive.
Right, right.
Where is this expression positive?
Is that between?
Exactly, that was the word I was looking for.
1
Between, I don't know. I'll determine it in a minute.
2 and 3.
I'll determine in a minute. With second and calc,
Right.
I want to find the intersect. So I want to find number 5. Right?
Yep.
So I'm looking at this number, which is somewhere between 1 and 2. 1, 2, 3, 4, 5, 6, 1 and 2. So I'm going to give the left bound. Second and calc. I want the intersect. 5. So the first curve, yes. The second for, I think better, so it doesn't ask me for all this, it's better to find the 0
Okay.
instead of the intersect. Because it's asking me where to find it, blah, blah, blah. So the 0 is the same thing, the x-intercept. Okay, so the left bound, I want 1. The right bound, I want 2. I don't want to guess. If you fall behind with this, tell me. And press enter. So I get 1.17. So x equals 1.17. Okay. Now I have to find the other one. It appears that the other one is at 4, but I'm not sure. So I go second in calc. I go to zeros. And then I say, I believe it's between 3 and 5. 3, enter, 5, enter. Just give me the answer. And it's giving me 3.9. Very good. So now, our conclusion. Paul already told us what the conclusion was. So in order for the volume to be greater than 200 cubic inches, what x should we choose? Where should x be?
Between 1.7 and 3.5.
Because that's where this function that we just graphed is positive. Awesome. Very good. Well done. Exactly. That was part B. Part C. Find the largest volume that such a box can have. So how do I continue?
The largest one?
Say it again.
Can we use the same graph and find the maximum?
Volume now. We're not talking about greater than anything.
Yeah.
So now which function do I have to graph?
Well, we got the 4x cubed times
Yes,
4x squared.
but I want it factored now.
That's right. X cubed. Oh,
Why do I want it factored instead of the whole blah 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 thing? Because I can use. Thank you. Exactly. I don't need to mess with a calculator. There is no need for something like that. Perfect.
So, why can't you take the 4 out as well as the x? Is that?
You could, because x has to be a positive number. That's true. You could. Again, in this particular instance, it's still safe to write 0 to 6, not the whole thing. Right? It's still 0 to 6. X cannot be more than 6. If x is 6, you understand you don't have a box. If x is 0, you don't have a box. Right? So it has to be somewhere between 0 and 6. And Arib is correct. He said, okay, why do I still have to put the x in there? True. X is still, it's positive. I can drop x. Take it out of the chart because since it's always positive, it's not going to affect the outcome. However, this is 0 here, and this is 0 at 10, but 10 doesn't even belong in the chart, so it will be right here. So this will have positive. I'm sorry. I just... The question was asking us to find the maximum. It was not asking us to do this. I'm sorry. I just realized. So we have to put in the graphing calculator. We are not studying the sign. Sorry about that. Sorry. We have to put in the graphing calculator because it's asking us to find the maximum. My apologies. So here is the previous expression, but I have to delete it because, or clear it. Any questions? Any questions?
So we don't need like anything like x.
Hold on, just one second. You have to stop talking only because you may disturb them. They may not hear what I'm saying. So I'm sorry about that.
Sorry.
Yes, Arib, I'm sorry. Forgive me.
So we just like get rid of everything we put before, even the x.
Yeah, because I'm not studying the sign. This time I'm only asked to find the maximum of the volume.
Right.
Sorry about that. I was still thinking of what we're doing before. Sorry. So I have to put in the entire function, and this is the entire function. I cannot miss anything. I cannot drop anything. Sorry. I cannot drop anything from this. This is the volume. We want to find the particular x. How long or how high the box should be for the volume to be maximum. So we have to find the maximum. We can find this maximum, but not in this class without a calculator. I mean, this is a very simple situation in Calc 1 with no calculator, but we can't do it now. So we have x cubed minus 64x squared, 4 x cubed minus 64x squared, and then plus 240x. My apologies. Yes, we go back to the viewing window. I have to have 0 to 6. I have y minimum still 0. It's the volume. I have no idea. I see it here in my little window. 200 is way too small. I'm going to go to 1,000 with a scale of 200. And graph. That's good. I'm too high, but it's okay. It's not a problem. I can see it perfectly. So this is 0 to 6. Somewhere between 2 and 3, there is a maximum. And I have to determine it. This time with second and calc. And I will be choosing the maximum, number 4. So choose 4. And I know I see the maximum is somewhere between 2 and 3. So I'm going to say 2, enter, 3, enter. It will give me, enter again, I'm not going to guess. It will give us the maximum. So when x is exactly 2.43, x approximately 2.43, what will be inches, of course? What will be the volume of 2.43 roughly? Approximately 263, I would say. Measurement unit, please.
Just cubic.
Very good. Cubic inches. Very good. Or inches cubed is the same thing. I wasn't correcting you. I was just writing it. Any questions for me? Any questions? Okay, so this is a previous test that I would like to quickly look at. See what we really need to go over. Because many of these problems we looked at in class several times with different situations. So I'm hoping that we can skip some of these.
Wait, this is previous test for this class?
No, for English 101.
Yeah. What is it? I'm sorry, what is the answer?
The answer is x is approximately 2.43 inches, and the maximum volume of that number is maximum for sure, which is 263 cubic inches.
Okay.
Is that better?
Yes.
I think that number 1 is done. I think we had so many examples and we had a lot of experience with number 1. Would you agree? Okay, what about number 2? We had it on the classwork. It's the same problem. It's the same problem. I just copied it from the previous test. So this is the same problem. Are we okay with that? You have it in the class notes with solutions. Okay, so let's look at number 3. I think we had that, but maybe not exactly the same. So tell me if we need to do number 3.
I think so.
Okay, so let's work on number 3.
This one,
That's fine.
I know that we're not supposed to square, but that's what I want to do. So.
That's fine. So let's work on this for 1 minute, and then let's work on it together. Okay? Okay. I highly recommend please review and redo all classwork. I will have all solutions posted for you from all classwork. Okay? Yes?
Are we gonna get through all this today?
I really hope so.
Okay.
I really hope so. Yes, I really hope so. And I still have a little classwork for you. 2 little questions. contract, I don't see the contract applied. Perfect, don't forget the square root also on this. Yes.
Oh.
Yes,
But yeah.
perfect, and now you have one more step, awesome. How are we doing? So, how did we get from here to here one more time? Yes? Yes? Let's do that one more time. Paul? No, 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 no. When I square x squared, what do I get?
X to the fourth.
Yes, please. I want to see x to the fourth. Careful. How do we square binomial? How many terms do we have to write? When we square binomial, how many terms we write? Yes. Yes. So why did you cross this with this?
I was.
Okay, okay, okay. You didn't. When we square binomial, we get, one more time, everyone, I want to hear everyone say.
Trinomial.
Okay, one more time. When we square binomial, we get only 2 students, 3 students, I'm saying.
Trinomial.
Okay. Stephen,
Yes,
a trinomial.
a trinomial.
Yes. When we square binomial, we get a trinomial, right? Yes. Angela, when we square binomial, we get awesome. I want to see it, please, please. No. We cannot take the square root from a sum. We cannot break the radical if the radical is a sum, right? Okay? Do we need more time? Do we need more time on this? Well, as I said again, if you want to be successful, you should go back and redo everything we've done and make up that little notebook. It will help you in the long run. So the square root of a squared plus b squared does not equal the square root of a squared plus the square root of b squared. That's the first thing. You can't do that. So the square root of x squared y squared plus 1/2 x squared minus 1/2 y squared, everything squared. So I have to copy x squared y squared plus. Now this is one chance in which we should put this behind us, right? That's why I created that little joke with you, or game if you want. If we have difficulties with this, we're going to have difficulties moving forward. First term squared.
1/4 x to the fourth.
Minus 2 times the first times the second. 2 times 1/2 is 1. So this is minus 1/2 x squared y squared plus this is 2 times the first term times the second term plus the second term squared. Y to the fourth. Very good. Awesome. So now we have to combine these two because they are like terms. This term with this term in the middle. So then we get 1/4 x to the fourth, but this time plus 1/2 x squared y squared and plus 1/4 y to the fourth. Now if you carefully look at what we just wrote here and compare it to this one, we should have no difficulties in writing what's under the square root. Can anyone dictate what is under the square root?
1/2 x squared plus 1/2 y squared squared.
Final step. Now I can take the square root from something squared.
So you end up with 1/2 x squared plus 1/2 y squared.
Yes, the only question I have, do I need to write absolute value?
Yes.
Let's analyze the quantity we obtained before we say yes or no. What kind of quantity is this no matter what?
Positive.
What type of quantity is this no matter what?
So it's positive.
And if we add two positive quantities, what kind of quantity will we always get? So do we need to put an absolute value on a positive quantity?
No.
No.
So if we put absolute value on that, we
I
would
have
get
to, yes, a little bit.
Wait, what happened to the beginning x squared y squared?
1 apple minus half an apple is half an apple. 1 apple minus half an apple is half an apple. $1 minus 50 cents is 50 cents. Better?
Yes.
And that's the reason why I can do this. Because otherwise I won't be able to factor it like this. It has to have 3 specific terms. Otherwise I won't be able to factor it. Okay, are we okay with this one? Yes?
No.
That's all 12. So, is it done? Okay, let's work on it. This is a 30-second, 20-second. It takes longer to write it than solve it. We talked in, you were not here, I think, when we talked about rationalizing the numerator or the denominator. Okay, back in chapter 1, this was done in class. Please review everything. Sometimes I go back and I choose problems done in class. And when students say, I don't know why I failed, I say, look, it was done in class. So please redo the problems we did in class and we do in class.
The denominator. So
Okay, can anyone explain what to do?
You multiply it by
the numerator, but change the sign.
Right, but the conjugate, very good. The numerator is in our contract. Again, if you'd like to be able to move forward, you will analyze those 3, practice them, and take them out of the way. So what does the numerator equal to?
x minus x plus h.
Yes, but it has to be in parentheses. If it's not in parentheses, then we mess it up. Very good. So then the top would be, after I distribute and combine like terms, x minus x goes away, and then negative h. So negative h over h, the square root of x plus the square root of x plus h. And I should have asked you similar, very similar to the difference quotient, obviously. What goes away now?
The H's.
Very good. 1 and 1. Don't forget to write 1. So this is negative 1 over the square root of x plus the square root of x plus h. Very good. I copied this problem on your classwork. I think we're okay with this, I hope. Yes? Okay, let's look at these 2, B or C. Any questions on B or C? Would you like to work on B or C? Or move on? Paul?
Let's go look at B.
Let's do B. Very good. Let's work on B. Okay, 1 minute.
Quadratic like,
Say it again.
quadratic like
In form.
in form.
Exactly. Exactly what you said. We like to say it's quadratic in form. Very good. How many solutions will you get? Yes, very good. 4 solutions. Let's do it.
How are we doing?
Oh,
Do you have time to review the class notes and the videos and
yeah,
please?
yeah.
I don't want to lose anyone. In this class, the material accumulates so fast that it becomes overwhelming at some point in time. And I don't want that to happen. Just study a little bit every day. How are we doing? That's perfect too. You didn't use a substitution, but this product is not that. Be careful.
Oh, yeah.
Oh, no, we are working on B. We're working on B.
Wait, but is this
No. Please erase that. Yes, awesome. Don't forget to write the 0 here, equals 0.
oh, okay.
That's fine. And
then substitute
yes,
that.
and this is not required on 1
Oh,
only
right,
because it's 1.
Yeah.
It's not a mistake. If
Okay.
you leave it like that, you get full credit. But since it's 1, we don't need to put 1.
Okay.
How are we doing? No. Please no. Please no. How are we doing? Oh, I know. Angela, how are we doing? Please no. No.
Again, I'm kindly asking you to redo what we did in class. Please. Please. Okay. So we noticed like Joey, before I even write it, finished like he's like Tom from the other class. He said, okay, let y be x squared. You don't have to. You're correct. You don't have. If you can factor it without using a substitution, it's fine.
Yeah.
So that means that this is y squared minus 3y plus 2 equals 0. And the factor form is y minus 2 and y minus 1 equals 0. And yes, you get 2 solutions in y. Exactly what you wrote, but without the substitution, which is fine. So now this equation becomes x squared equals 2, and this equation becomes x squared equals 1. That's why I asked you from the beginning how many solutions I expect, so that I don't make a mistake. From the get-go, I look at it, it's not quadratic, it's a polynomial, it's quadratic in form, has degree 4, it has to have 4 solutions. So now here I know which method. We have 4 methods of solving quadratic equations, but we will take the square root. That's the best method. From here I get 2 solutions as plus or minus the square root of 2. And from here I get 2 solutions as plus or minus 1. Please review all problems we did in class. If a problem was not on this test, but we did it in class, it can still be on your test. Okay, so do not say, oh, this is it. That's all I have to study. Please. This is an example. This is what happened last semester. Okay, do we need to work on C? Okay, so let's work on C. 1 minute.
if you want to have a good foundation and move on to Calc 1, Calc 2, and so on and so forth, what you're trying to do, this is absolutely mandatory. And I have to say that my heart does go out to you. I don't think that O12 prepares students for this class. Not enough. Not enough. There's so much. So what are the two keywords that we have to have in the back of our minds all the time in math? And factors. So what will you do with this first? Fully simplify it. We cannot factor this one, but we have to fully simplify it. This was a topic in O12. This is not from this class. We review it in this class, but how are we doing? Awesome. How do you clean it up? No, we cannot touch the absolute value. The absolute value is completely untouchable. We cannot put anything inside, we cannot take anything outside. We have to fully simplify the equation. Again, we had examples at the beginning of the course from this. So what will you tell me to perform first?
Get the absolute value by itself.
Exactly. Without that, I can't solve anything. I cannot solve the equation. So I move 14, so I get -8, and I divide by -2, so I get 4. That is the mandatory step. I also like to say to my students, clean it up. Move 14, divide by -12. And now I know there are two possibilities here. What can this inside be? What are the options for the inside? 15? No, because the absolute value of 15 is not 4. 39? No, because the absolute value of 39, I'm trying to be funny. That's it. So 2x minus 3 can be 4, or 2x minus 3 can be -4. That's how I build, and I hope I'll help you think. So always, every step of the way, ask yourselves questions. What is it? What should I do first? What am I asked to determine? How do I get there? What is the next step? Things like that. Instead of just, let me mimic with something else that is in the book somewhere. Yes, Joey?
You could also do 2x minus 3 equals 4, or -2 plus 3 equals 4. Would that also be right? Because I got the same answer.
Say it again. 2x minus 3 equals 4, or negative parentheses.
Equals 4 or equals
Yes.
-4. I did the reverse signs on what was in the
Right, it's the same thing.
Yeah.
But I think the logic, which is okay, whatever works, every brain is different. What is very easy for you, it may be completely impossible for me.
Okay.
Right? So I show my students a method. You can tweak it, you can change it, you can invent something else. I'm fine.
Okay.
So I move 3 and I divide by 2. So x is 7/2. I move 3 and I divide by 2 and I get -1/2. Okay, moving on. Any of these? Again, this is part of O12, this is not. This is what we covered in this class, but that's part of the previous course. So, any of these two? B? Do we still have to do A, or we move on to B? No, this is an inequality. I think we should do A as well, okay? Just to make sure. So let's think about this. Do not change inequalities into equations unless you're solving like we did. Let me show you what I mean. See, this is an inequality, right? I did not change it into an equation. This is an inequality. I changed it into an equation temporarily to find the solutions using the Corati formula. But then I went back to the inequality. So the purpose here was to write the equation in descending order so I can use the Corati formula, which I cannot use in an inequality. So this was just temporarily to determine these two. So this is an inequality. Please do not change it into an equation. Okay,